Well, welcome to the invited speakers session. I think this is the third of the invited speaker sessions, and we have some really great speakers here today to talk about some very different things related to high-performance computing. So the first speaker is Satoshi Sekiguchi, who is the Vice President of the National Institute of Advanced Industrial Science and Technology, or AIST, as many of us know it, in Japan. He is also the Director General of the Department of Information Technology and Human Factors. He's worked a lot in HPC and system architectures to applications, including technologies for global environmental monitoring, smart manufacturing for precision and quality, and AI security. He's going to be talking today about AIST's new AI Bridging Cloud Infrastructure, or ABCI. Please welcome him.
Okay, thank you very much, Kathy.
Thanks.
Okay, so good afternoon, everybody. Thank you, Kathy, for your kind introduction about me. So again, my name is Satoshi Sekiguchi, Vice President of AIST Japan. It is a great honor for me to have such a memorable opportunity to give a talk at the SC18. So today, with this given 45 minutes, I will be presenting an overview of our ABCI project and some background story about why we do this. So the outline of my talk will be the following. First, I'll give some introduction about our organization. Then I will describe the current status of ABCI. Then I will share the Japanese strategy to tackle the digital transformation of society in details. So before we move on, quickly, I'd like to introduce my organization, AIST, so which is the owner of the ABCI. AIST is one of the largest Japanese national research institutes that conduct research with a focus on applied industrial science and technology rather than the basic sciences. Our goal is to help bridge the gap between research and commercialization. As we are engaged in industrial science and technology, our vertical headquarters is METI, which stands for Ministry of Economy and Trade and Industry. So from a historical point of view, in 2001, AIST combines 15 research organizations into a single independent administrative institute. However, AIST started back in 1882, and the first computer-related department, the Electrotechnical Laboratory, was established in 1891. So celebrating the 30th anniversary of Supercomputing Conference Series, I borrowed an old picture from the dawn of Japanese computer development. To the left is the first program-stored computer made of junction transistors running a clock of 180 kilohertz in 1957. Literally, there are neither tubes nor relays. Bottom left is the gray XMP Q16. We were the first customer in the Japanese public sector. We ran the machine with Unicos, which is a System 5-based Unix then. On the right hand, here, this is the research prototype of the instruction level data flow machine called Sigma 1. So it was with 128 processing elements, which is developed back in the 1970s, 87. So currently, we have 7 different research departments that cover a broad range of scientific domains. The department that I direct is the Department of Information Technology and Human Factors. We have over under my department, we have over 300 research scientists employed with the annual budget of around the 10 billion Japanese yen. It's close to the 100 million US dollars. So, ABCI status. So given us very strong push in artificial intelligence research and development, we have received a 20 billion class project to develop and promote R&D research for the artificial intelligence. So as I said, we have received 20 billion Japanese yen, which is about the 178 million US dollars. But the award covers the building and the facility for the research. That was the first place. And secondly, we prepared the kind of the environment where we wanted to set up this kind of the virtual manufacturing or virtual service facility, so that the people may walk around and then we sense such a behavior or something, so then they capture many of these data. And also, we have a lot of the sensors to capture such a human behavior and then the group activity or the process of the manufacturing industry. And finally, the ABCI. So actually, these are the four. Actually, for the ABCI, we received 5 billion Japanese yen for the building such a system. So it was about 44 million US dollars. And then the AIST, our ABCI, we decided to build such a facility, not on our original campus, which is actually located in Tsukuba area, but between University of Tokyo and the AIST, it agreed to have such a facility on the University of Tokyo's campus. So that there is a kind of an expansion of the University of Tokyo. The campus is located in Kashiwa, so which is also called Kashiwa Second. As for the ABCI, we wanted to build the kind of the world's first large-scale open artificial intelligence infrastructure. However, we set up the sort of the regulation. We are targeted at that time of we received the award, our artificial intelligence flops, the meaning almost close to the 16-bit floating point operation, but we are targeted around 200 petaflops. And then also due to the facility limit, we had only 3 million watt for the as a power budget. And then also saving the running cost of such a big machine, we were targeted at the less than 1.1 PUE for the better energy consumption for our system. And then ABCI will be a kind of an open public dedicated infrastructure for artificial intelligence and big data algorithms and software and applications. So that's a kind of the platform where we do a research, we invite the small, medium sectors to work on in the ABCI and some other ecosystems. And then this platform to accelerate the joint academic industry R&D for artificial intelligence in Japan. And then the good thing is that we are targeted to operation all the system ready in the first quarter of this year. So we received the award in 2016, and will be the system operational the less than 24 months. Okay, so these are the looking of our data centers. And then the building next is for the research. the building where the people are working. So combining this in the data center and the research building to do more IoT studies and the big data studies, etc. And then the size of this in the building is the 432 square meters. And with the size of the 18 meters width and the 24 meter depth and the 8 meters height. But the development of this in the building is quite unique. So we set up the kind of a hard concrete floor to tolerate the 2 ton per square meter weight. And then on that floor, so we have a lot of heavy computing system just directly on the floors. So again, the power capacity is like this, and then the cooling capacity is as well. So as I said, we have to do it less than 24 months. So the construction of the building is quite quick. So you see here is the first picture. Just started the construction. It was the October 30th. And then just making the basement, and then the building is started the build in the first week of December, and the finally end of January. So the building is ready. And then almost in the February or March time frame, the building is ready to go, and then we start the installation. So this is the picture of the ABCI for now, and then you see this is the whole the view of the ABCI, and then this is the whole aisle of the ABCI racks. These are the front view of the few racks of a part of the ABCI. So each rack contains 34 computing nodes, and the interconnect network equipment are sitting in the middle. The actually standard computing node configuration has 32 racks on of 1,088 computing nodes. So in addition, we have several supplemental nodes. In total, all nodes are capable of 550 petaflops, but with a floating point at the FP16, a floating point expression. So these nodes are fully connected within the InfiniBand, within a rack. And these racks are connected via the InfiniBand again. For external access, ABCI is connected to SINET 5, which is a Japanese university and recent research network within 100 gigabit per second. And then I know the SINET 5 is well connected around the world with the quite high bandwidth of the networks. So there are two components to consist of the computing node. The one is a CPU module. There are two sockets of the Intel Xeon Gold with 384 gigabytes of memory. And then these two black blocks are used for heat removal from host CPUs and also the memory. On the other hand of this this block, so there is a metal is attached, and then the metal contacted to the CPUs, and then they remove the heat. Then similarly, for the GPU board, we have 4 NVIDIA Tesla V100. And then the CPU blade and then GPU blade are stacked. and then the 2 stacks goes into the single computing in chassis, and then with a 2U height. Yet another feature, a unique feature of the ABCI is the cooling mechanism. So we decided to have the hybrid cooling model, which I mean, basically the CPU, memory, and the GPUs are the liquid cooled, but the other part of the component are air cooled, so that they are kind of a hybrid the mechanism we have designed. And for make things much effective, we designed the computing rack from the scratch. Actually, these looks at two stories, the racks, and then the lower half is prepared for the CPU rack as. And also for the upper part is some sort of the air ventilation or air circulation is used for this in the second story. So this in the hybrid cooling system, as I said, we intake the water at 32 Celsius degrees, and then we output the water at the temperature of 40 Celsius. And the other part, the air brought within the system, and then we separated in the cold aisle and the hot aisle to make more effective the ventilations. So that is a very unique feature for the cooling of the ABCI, and then they contributed to save our energy. So here is some movie, which is trying to build our system under the roof, and then we started this construction, and then actually you see that the lower part. Well, maybe you don't believe, so this is the building the computing rack. So it's something like the building and construction, but the lower half, and then which is sitting on top of the flat floor, we didn't pay much attention for the anti-vibration from the earthquake or something. So just we built this system on top of the floor. So finally, so the lower part is for the computing, containing computers, and the upper for the air ventilations. But the people were skeptical that kind of the passive cooling could perform well in hot summer Japan. But in fact, the highest temperature for the case of the late July, so the highest temperature went over 37 Celsius. So also at that time, we did a kind of the first ground challenge trial, and then so there are a bunch of the CPU requirement, and then the temperature goes high. But finally, we successfully survived, and even the outside temperature goes much higher than the water. So we maintain the intake water less than 32 degrees, and then the output water is managed at less than 40 Celsius. And also, we keep the 8 degrees as the kind of the good cooling of the system. So finally on Monday, probably you may be aware of the November list of the top 500 which was released. According to the list, ABCI captured the number 7 spot on the top 500 with 19.8 petaflops. Yeah, of course, that is the double precision. And also the number 4 spot on the green 500, so where ABCI delivered a power efficiency of 14.4 gigaflops per watt. Although these ranks are not number 1 spot, but this shows that our machine is well balanced between the power and the efficiency. So, maybe the last part, maybe the second part of my talk, why we did this kind of a project. So besides scientific curiosity, what our motivation to build the ABCI? So here is an answer. In the latest couple of years, the Japanese government is strongly promoting Society 5.0. And even scientists are investigating Society 5.0 too. So in Japan, everyone talks about it now. But nobody really knows how to do it. But everyone thinks everyone else is doing it. So everyone claims they are doing it. So what is the Society 5.0?
The fourth industrial revolution will enable us to create a new society. Artificial intelligence will transform the big data collected through the Internet of Things into new wisdom. Society 5.0, a technology-based, human-centered society. The fourth industrial revolution will raise our standard of living and solve various challenges we face. It will, for example, free us from the stress of driving, allowing us to safely visit anyone, anytime. We will have access to the latest medical advancements at a low cost, no matter where we are. AI and robots will enhance human ability and expand our infinite possibilities, helping us enjoy more fulfilling lives. Society 5.0, for the betterment of human lives.
Okay. So this is actually our official PR movie of Society 5.0, but how do you like it? So it will give us some hint of our future. So trying to make a balance economic advancement with the resolution of social problems, and which brings about a human-centric society. But as you may know, that the Society 5.0 is a future which realizes the advanced fusion of the cyberspace and physical space. But whatever our future vision looks like, we are quite confident that artificial intelligence will be the key technology to enable this in the future. So yes, it is a long history that research scientists work on the advancing artificial intelligence for many years. So, well, actually, the first wave, they came in the late 50s. It was a real epoch-making study. But you remember the time of the early 50s? So that was the time of we have just a transistor type of the computer at that time. And then second wave came in the mid-80s. And then the third wave is very hot for now. So I'd like to note that there is the so-called AI artificial intelligence winter, AI winter, in between the second wave and the third wave. So at the time of the mid-80s, there was the fifth generation computing project, which was an to realize the artificial intelligence into the real world. And then the Japanese government, they put a lot of money to build the fifth generation computers to help to accelerate the kind of the inference by using the parallel computer system. But this is the build from the scratch. And then actually this model, which I got, made it, so-called the PIM-P machine in 2001. Again, so it was at the time of the Cray 1 or Cray XMP and the Sigma 1. So to accelerate such the advanced technology, we conducted kind of a code design of these systems. So that was the second wave of artificial intelligence. And then also the funny thing is that at that time, almost at the same time, so they published kind of the great note about the artificial intelligence application and the technology. Well, I had a chance to read through the report, and then they find out, oh, okay, so this one is still useful for the today third wave of the artificial intelligence. Nothing real, no, not nothing, but just a limited portion of these people are realized at this time. And before going on to the third wave, again, I said, so here is the AI winter. But at the time, between the second wave of the artificial intelligence and the current third wave of the artificial intelligence, the Japanese government put a lot of the effort trying to build the faster machines. So, and then they also, for the software part of the project, so there are a lot of the data-driven approaches they performed. And these are actually, so these are the cluster technologies, which is followed by the grid computing or the cloud computing at the time. And then recently, the deep learning became a truly feasible solution and is supposed to change the society and the industry. So that's kind of the story we are following. However, so this is the actual recent study performed by the IPA, which is an information promotion agency. It's one of the government agency, and which shows that the 90% means of the SMEs are not ready to utilize artificial intelligence. Only 10% is ready to have the advantage of the artificial intelligence. So based on the right-hand side, so based on the total revenue, many SMEs, within the annual level of the annual revenue is lower than 10 billion Japanese yen, so which are still having a disadvantage because they lack resources. They actually to deploy artificial intelligence for their real business. So, although I said so there are the big boom or campaign about the Society 5.0 and then the artificial intelligence is supporting technology to make things that they happen. But the reality is that the SMEs a little bit feeling a little bit difficult to deploy such an artificial intelligence for their day business. Again, so this is actually happening in Japan. I'm not quite sure. US may be different and Europe may be different, but this is actually happening in our country. So they take a look at this segment that there are user companies and the IT vendors who has the strong the IT investment or lower IT investment. So currently, if the user company has to understand, okay, artificial intelligence is the good thing to go. So you put a lot of the money to build maybe your own artificial intelligence application or something, or even you can work together with an IT giant to make your customized and artificial intelligence, so which makes you receive more higher competitiveness. And for the IT vendors, if you have a good customer, you can gather more data. And then once you gather such a data, so such customer don't want to get out of your your company, don't want to leave your company. So there is a kind of a lock-in strategy. But for the lower case, so the people don't have a lot of the money for developing the new IT or new AI. So because I don't know how to use artificial intelligence for my business, or I have no idea how to run such an IT system for my business. And then also even the IT vendors, the system integrator, who has no place to run such a big data, or to develop their system, or application vendors is the same things. It's not, there is no place to develop such an AI-ready package. So that causes, so there's going to be the widening the gap between the high investment versus low investment. It's a good and bad, of course. So ABCI, of course, would help such small, medium enterprises and then IT business, the partners, by providing the resources as a kind of an open AI, where even they don't have that much computing resources. Okay, we can give you some portion of our system, or we will help to manage the IT system. And also for the IT vendors, so you may try to use our system for your, the development or something. So the sitting underneath of the layer, the AIST is offering such an infrastructure as a kind of a safety net, or the accelerating such the business. So the summary, maybe. So historically, so Japanese approach to artificial intelligence has always included infrastructure and software. So you have seen that our 5th generation computing project, of course, there are a lot of the effort to develop the kind of an expert system, or the kind of the languages, etc. Well, as well as such a software project, we had building the system of the parallel inference machines. And also, at the time of the real-world computing partnership, so there was so-called, in the period of the AI winter, we developed the data-driven the pattern recognition package, but also we have developed the kind of the cluster-based the computing technology. And these are actually leading to our current effort within ABCI. So of course, the deep learning type of the research, as well as the ABCI type of the infrastructure research, is the key to the future. So ABCI, we haven't designed our system to achieve a high ranking in the top 500, but so ABCI was created to address the specific needs in the Japanese society. So of course, we we are awarded by the Japanese government. So our primary focus is to help our SME partners and to utilize artificial intelligence type of the business or something else. But they're not only for doing this for the Japanese, the SMEs, but also they want to make it the more global partners. So we strongly encourage you to contact us how to find out what's the possible way to work together. So some of the program we created, which is an open proposal program for the research teams to use the ABCI for computing capability. So yeah, of course, there are certain contract we needed, and there's some sort of the selection process. But this would be a good opportunity for doing the kind of the scientific grand challenge. The next, the submission deadline will be coming shortly, but we continue to offering this in the grand challenge for the future. So please don't forget the next time or the next time afterward. And then one of the outcomes, so we just received yesterday, the Sony Corporation, and which used our ABCI under this in the grand challenge in the program. So they claimed that they achieved the world's fastest deep learning speed through distributed learning. So this is, it's hard to tell you, but the ImageNet ResNet 50, it's a kind of the benchmarking. But about 3 years ago, it took over 29 hours. And then, of course, according to the development of the new hardware, that time is the improved. And then finally, even the same, the error rate, similar error rate, but the Sony team, achieved 224 seconds. It's about 400 or more times faster than about 3 years ago. So that's a quite impressive outcome that we are having. So ABCI now for changing in the future. We are happy to work together with all of you. And then, okay, thank you for your kind attention. Oh, maybe lastly, so if you have a further question, please visit our booth. They're located at the 2409 for the future details. Thank you very much.
Well, there's time for a couple of questions, and there are microphones in the aisles if anybody would have a question to ask. Please say your name and institution before you ask your question.
Hi, Earl with Hyperion Research. I was wondering, for the applications you're running today and the near future, how many do you think will be more machine learning or versus deep learning? Do you have any feel for that?
Well, it's up to the customers, so we don't want to control. But well, maybe for the kind of the huge scale of the certain applications, the deep learning types of app will be dominated. So the more deep learning, maybe. Yeah, of course, the people are still developing the other types of the machine learning type of the application, but we don't want to control. Yes.
Great. Well, I also had a question. Sure. I was just wondering, you're obviously focused on how to provide the computing necessary to make progress in AI and machine learning. I was just wondering, the other thing that people say they need in order to compete with some of the large companies that are doing this is access to data. So is there sort of an integrated plan for how to get access to more interesting data sets in this space along with the computing?
Yeah, that's right. So well, the data isn't the key, of course. Well, at the big enterprises, they have other kind of their own data, but it is all proprietary. Right. And then for receiving such a huge data to be a source of the machine learning, so we need to have a kind of a separate contract, how to deal with such a big data. So yes, we are heading to combine the large enterprises and the small medium enterprises, but the need to, well, they prepare such a legal issues, of course.
Okay, well, thank you very much again.